Hey guys, I hope you're doing well. So in this lesson we'll talk about the unit circle, sine, cosine and tangent functions. And I know you remember this from your earlier classes because most of you know what SOHCAHTOA is. SOHCAHTOA was a chief of some tribe in the Amazon forest. But I'm pretty sure that you remember what SOHCAHTOA is from your math classes. So in class today we were not able to finish this example, but I did it on the video. However, I'm just going to do it here again to probably help you explain this more if you need that explanation again. So it says the diameter is 120 millimeters. That means the radius is 60 millimeters, but you have to change that to standard units, which is 0.06 meters. Then it says that the angular speed varies and the linear speed is constant when it's being read. When reading the outer disk, the angular speed is around 200 rpm, and they want us to find the linear speed. So we know v is equal to omega r is the equation we're going to use to find the linear speed. But to use that equation, we need to first know what omega is, and that has to be in radians per second. Fortunately, we've been given omega, it's 200, but it's been given in revolutions per minute. So we need to change that revolutions per minute to radians per second. I hope you remember that one revolution has 2 pi radians, right? This is a very important conversion factor. One revolution is 2 pi radians, or one rotation is 2 pi radians, or one cycle around a circle is 2 pi radians. So since one rotation is 2 pi radians, then 200 rotations is going to be 200 times 2 pi radians. And remember, it was radians per minute, but instead of minute, I'm going to change this minute into seconds and now say radians per 60 seconds. So my omega, my angular velocity, is going to be 200 times 2 pi divided by 60. That is my angular velocity, and that answer is in radians per second. So since I found that answer, the angular velocity, I'm just going to substitute it in this formula for linear speed, which is omega r. And I'll just say this is 400 pi divided by 60 times the radius, and that radius is 0.06 meters. So you'll be able to get your answer in meters per second. Okay, starting with this lesson, a unit circle is a circle with a radius of 1 unit. As simple as that. If this radius is 1 unit, then it's called a unit circle. If it was 2 units, it will be called a 2-unit circle. If it was if this circle had a radius of root units, it would be called a root circle or a ruthy circle. I don't know. So in a unit circle, if you think of this as a unit circle, the radius is 1 unit, so that means this is also 1 unit. But I have this triangle here that is a right angled triangle, and this distance from this point to this point is the y value, is the y distance, because if this is the y point, then I have this, whatever y is, let's say y is 3, then up here will be 3 units, right? And that 3 units is the same as these 3 units. So I'm just trying to show you that this y value, the y coordinate, is the opposite side of this right angled triangle inside the unit circle. So if I want to find the sine, remember sine is equal to opposite over hypotenuse, right? The opposite is y, and the hypotenuse is just 1 because this is a unit circle. So I end up seeing that in a unit circle, the sine of theta is just y. What about the cosine? Again, this is y, and just using the same principle, the same thinking of if this is y, then this opposite is y. Then if this coordinate is x, then this distance here is also x, or that base of the triangle is x. Remember, the 1 unit is the radius, so it goes all the way to the end of the circle, but just the distance from the center of the circle to this position here is x. And if I want to find the cosine of that angle, remember cosine is adjacent over hypotenuse. The adjacent is x and the hypotenuse is 1. So we see that the cosine of an angle in a unit circle is equal to just the x coordinate of wherever that point is on the radius. The x coordinate that point made by that angle has on the circumference of the circle. The tangent, remember tangent is opposite over adjacent, right? I'm getting these things from SOHCAHTOA. Opposite over adjacent, the opposite in this case is the y value and the adjacent is the x value. So this is just y divided by x. This shows us an interesting thing because we know the y is sine and the x is cosine. So this is something to note for the future, that tangent of theta is the same thing as sine theta divided by cosine theta. I'm pretty sure you did this before in your earlier classes, but it doesn't hurt to be reminded. We'll see this a lot going forward, that tan theta can be expressed as sine divided by cosine. So if I want to find the exact values of trig functions, for example, if the angle is pi over 2, what would the sine of pi over 2 be? Or the cosine of pi over 2 be? Or the tangent of pi over 2. So you need to remember these, really, you need to remember these, but I'm going to show you where they come from. The sine of 90 degrees, because this is 90 degrees, the sine of 90 degrees is just 1, the cosine of 90 degrees is 0, and the tangent of 90 degrees is undefined. Right, undefined. Because, let me show you, on this image, imagine this is your triangle, and this is the angle here, the angle over here. I hope you can see this angle. Let's say the angle over here is the angle that we're going to be changing, right? We want to see what happens when this angle becomes 90 degrees. So I'm going to keep increasing the height of this triangle. So I know sine is supposed to be opposite over hypotenuse. Currently this line here is the hypotenuse and this line here is the opposite. And this angle is some value. Maybe right now it's around 45. But if I keep increasing if I keep increasing the opposite side, if I keep making it higher and higher and higher and higher, because the objective is to get this angle down here to be 90 degrees. So if I keep making the opposite side taller and taller and taller, because doing that helps me to get a 90 degree angle, I hope you can see that the taller the opposite gets, the closer it becomes to being equal to the hypotenuse. So if you go higher and higher, and I hope you see this angle down here gets closer and closer to 90 degrees, and at some point when that angle is equal to 90 degrees, I don't know when I'll have to zoom until to get to that position, but when that angle is equal to 90 degrees, the opposite and the hypotenuse will be equal, right? The opposite and the hypotenuse will be equal, and when they are equal, that's why the sine will be 1, because sine is opposite divided by hypotenuse. So if the opposite is equal to the hypotenuse, the sine of 90 degrees is 1. The same logic can be used for the cosine of 90 degrees. So when we look at this triangle, because the cosine is supposed to be adjacent over hypotenuse, right? when we look at this triangle, when those two are equal, there is no adjacent side. I hope you can see that at the base these points are the same, right? When those two are equal, there is no adjacent side, so the adjacent is just 0. So therefore, the cosine of theta, the cosine of 90 degrees, will be adjacent divided by hypotenuse, but I don't have an adjacent side because the triangle has a 90 degree angle. So that will be 0 over, like, whatever it is, infinity. 0 divided by anything is still going to be 0. The tangent of theta is supposed to be opposite over adjacent. Now remember, the opposite was so big, probably infinity, and the adjacent is 0. And remember, division by 0 is undefined, or some of you say impossible, or etc. But the correct mathematical term is to say that it's undefined. So that's why the tangent of 90 degrees is undefined. So you just need to remember that sine of theta is 1, cosine of theta is 0, and the tangent of theta is undefined if that theta is 90 degrees. Let's look at 180 degrees. So I'm going to post this link on your classroom, and you can play around with this triangle to visually get an understanding of how these triangles come to get their ratios. But when the angle is 180 degrees, the sine of theta will be 0, because it would be opposite over adjacent. If the angle is 180 degrees, you don't have an opposite side, right? If the angle is 180 degrees like this, the opposite side is equal to 0. So you don't have any opposite side. You just zoom in again so that you can see Oh, still have something. So when the angle is 180, because 180 is a flat line, then you don't have an opposite side, right? The opposite side is 0, and the hypotenuse, it doesn't matter what the hypotenuse is, but if this is 0, then the sine of 180 is going to be 0, or the sine of pi is 0. The cosine of pi should be adjacent over hypotenuse, but in a triangle that looks like this, the adjacent, because remember this was the hypotenuse, but it's now down to 180 degrees, and it's equal to the adjacent. This was the initial adjacent, and it's now equal to the hypotenuse. So that's why the cosine of 180 degrees will be equal to 1. The tangent of 180 degrees, in this case, look at it and see, the tangent is supposed to be opposite over adjacent. So what do you think that will be? Or another way to think about it is the tangent of theta is supposed to be sine theta over cosine of theta. The sine is already 0, the cosine is 1, so the tangent also has to be 0. Even if you had used this approach, the opposite was still 0 because there was no height of the triangle, so that gave you a 0. So yeah, you just need to remember these values. The sine of 180 is 0, or if you don't remember, you'll keep punching it into your calculator until you remember it completely. 3 pi over 2 is 270 degrees, which is over here, 270 degrees. The sine is -1 because it's the opposite of whatever this is here, 90 degrees. The cosine is 0, and the tangent is also undefined. You can see how this works on the link that I'll post. 360 degrees is basically the same as 0 degrees. The sine of 0 will be 0. The cosine of 0 will be +1. Here the cosine of 180 was supposed to be -1. Sorry about that. The cosine of 0 will be +1. I will explain this when we get to the quadrants. The tangent of 0 is also supposed to be 0 because the sine is 0. Alright, special right triangles. I know you talked about these in your previous classes, and I'm just going to go a bit into detail in this about these special right triangles. So imagine you have a uniform equilateral triangle. Oh, sorry, those words mean the same thing. A uniform or equilateral triangle, they are the same thing. Uniform, equilateral. 60 degrees, 60 degrees, 60 degrees. And this triangle has a side of 2 units. So I have 2 units here, I have 2 units up there, and I have 2 units up there. If I decided to split this triangle in half, right, in half, forgive my drawings, if I split it in half, this side will be 1 unit, this side will be 1 unit, this side will be 2 units, this will be 60 degrees, this will still be 60 degrees, but this will be 30 degrees, and this will also be 30 degrees. Now, because I have these angles 30, 60, I can find their ratios. I can find the sine, cosine, and tangent. But I will need to find this height of this triangle. So, when I use Pythagoras, I have 1 here and 2, and this is 60 degrees. I can use Pythagoras to find the height of this triangle, because I know 1 squared plus h squared is supposed to be equal to 2 squared. That means h squared is equal to 2 squared is 4 minus 1 is 3. That means h is equal to the square root of 3. So this height is going to be the square root of 3. That's where this triangle comes from, this one here. A 30-60 triangle, that's where it comes from. It's just flipped around here in the way it's drawn. So from these triangles, I can find all the trigonometric ratios. I can find the sine of 30 using SOHCAHTOA, because remember SOHCAHTOA is opposite hypotenuse, adjacent hypotenuse, and opposite adjacent. So the sine of 30 will be the opposite, which is 1, divided by the hypotenuse, which is 2. The cosine of 30 will be the adjacent of 30, which is √3, divided by the hypotenuse, which is 2, and the tangent of 30 will be the opposite of 30, which is this one, divided by the adjacent, which is √3. But in math, we don't like to leave square roots in the denominators, so I'll get rid of that square root by multiplying it up and down, which doesn't change anything, and I'll end up getting √3/3. So when you see it written this way, it's still the same thing as 1 over root 3. Consequently, I can go ahead to find the sine of 60, the cosine of 60, and the tangent of 60. So you guys go ahead and do those ones. You will find that the sine of 60 is root 3 over 2, the cosine of 60 is 1 over 2, and the tangent of 60 is root 3 over 1, or just root 3. Now I want you to notice something here, something interesting. The sine of 60 is the same as the cosine of 30, and the sine of 30 is the same as the cosine of 60. This is an interesting property of mathematics, a property of complementary angles, because remember, complementary angles add up to give you 180. It's such that the sine of 90 minus any angle, right, is equal to the cosine of that complementary angle. And the same thing is true for cosine. The cosine of 90 minus any angle is equal to the sine of that angle. I'll show you what I mean. Imagine we're using 30 degrees. The sine of 90 minus 30, right, should equal to the cosine of 30 degrees. Sine of 90 minus 30 is 60 degrees. So that should equal to the cosine of 30, and that's what we have seen here, right? So this is an interesting property of complementary angles in mathematics, and yeah, when it comes up again, I'll remind you that I talked about it in this lesson. If I want to find the exact, I didn't talk about the 45-degree triangle. If you have a triangle in which the legs are equal, these are the legs, this is leg 1 and this is leg 2, any triangle in which the legs are equal is a 45-degree triangle. This will be 45 degrees and that will be 45 degrees, and therefore that will be 90 degrees. Any right triangle in which the legs are equal is a 45-degree triangle. So if those legs are 1 each, I can find the hypotenuse, because 1 squared plus 1 squared is equal to c squared. That means 2 is equal to c squared. That means c is the square root of 2. So over here is the square root of 2. Therefore, from this triangle, I can find the sine of 45 degrees, which will be opposite over hypotenuse. Opposite is 1, hypotenuse is root 2. I can find the cosine of 45 degrees as well, which is adjacent over hypotenuse. The adjacent is still 1, the hypotenuse is still root 2. I need to get rid of the root 2 from the denominator, and I do that by multiplying it up and down, and I end up with root 2 over 2 for sine, and the same thing as root 2 over 2 for cosine. So what you notice here is that the cosine of 45 degrees and the sine of 45 degrees are the same exact thing, right? They are the same thing, root 2 over 2, root 2 over 2. And therefore the tangent of 45 degrees will be opposite over adjacent, which is 1 over 1, which is 1. So in a right triangle in which the legs are equal, the tangent is always going to be equal to 1 unit. I mean just 1. Yeah. You could also find this by saying tan is equal to sine over cosine, because remember we discovered that that's true. And sine over cosine is root 2 over 2, divide by root 2 over 2, but you do the KFC, so it becomes 2 over root 2, everything cancels out, and you end up with 1. So yeah, these ratios you need to remember, right? And an easy way to remember them is, as you're going to see, by putting them on a unit circle. So we've seen that the sine of 45, because pi over 4 is 45 degrees, I hope you guys remember this. The sine of 45 is root 2 over 2, the cosine is also root 2 over 2, and the tangent is 1, right? Now we've seen 5 pi over 6, what angle is this? Let's see, 5 pi over 6, if you want to figure out what angle it is, ask yourself, how far away is it from a full pi, right? So if it is 5 pi over 6, how far away is it from a full pi? What do I need to add to it to get a full pi? I need to add pi over 6, right, to get a full pi. So this pi over 6, that means is the reference angle. And you know a full pi is over here, so therefore 5 pi over 6 will be somewhere here, and that means the reference angle is going to be pi over 6. Or this angle that you added to get a full pi is pi over 6. Now, there's something about quadrants in trigonometric functions, quadrants on this unit circle. In this quadrant, all the ratios are positive. You studied this in 10th grade last year. In this quadrant, only sine is positive. In this quadrant, only tan is positive, and in this quadrant, only cosine is positive. An abbreviation people use is all students take coffee, or all, I don't know, you can come up with your own cool abbreviation to help you remember this, but it's always going in this direction: all, sine, tan, and cosine. So what this tells us, and what we know about these ratios, is that since this angle is the reference angle for this 5 pi over 6, the ratios of this angle are going to be the same exact ratios of this angle in magnitude, right? But in terms of the sine, then we have to respect, in terms of the sine, i.e. negative or positive, we have to respect these conditions for the quadrants. So 5 pi over 6 has a reference angle of pi over 6, and pi over 6 is the same as 30 degrees. So 5 pi over 6 must have the same ratios as pi over 6, which is the same ratios as 30 degrees. I hope you remember the sine of 30 degrees is a half. The cosine of 30 degrees is root 3 over 2, but it has to be negative because in this quadrant only sine is positive, right? Only sine is positive. The tangent of 30 degrees, I hope you remember, was 1 over root 3, which was the same thing as root 3 over 3, but it has to be negative because in this quadrant it's only sine that is positive. Alright, moving on. 5 pi over 3, ask yourself, what do I need to add to it or subtract from it to get a full pi? So 5 pi over 3 has exceeded 3 pi over 3 by how much? By 2 pi over 3, right? 5 pi over 3, what angle is this? Let me just convert it because it's confusing me as well. No, I'm not converting it. Okay, 5 pi over 3, let's do this. Mental math, let's go. 5 pi over 3 is the same thing as 3 pi over 3, right? A full pi plus 2 pi over 3, right? So a full pi, because 3 pi over 3 is a full pi, so we know we have gone here already. And now we just need to add 2/3 of a pi, right? We just need to add 2/3 of a pi. And I hope you guys remember that 2/3 of a pi, because this would have been another full pi, but we're just going to add 2/3 of that pi. I know 1/3 is 60 degrees, right? And therefore 2/3 will be 120 degrees. So that angle is going to be somewhere here, right? This is going to be our 5 pi over 3. So just ask yourself, what am I missing? I mean, what angle is missing here? One way to do it is to say, if this is 2 pi and this is 5 pi over 3, I can subtract and see what's going on, right? I can subtract 2 pi, which is 6 pi over 3, and I can subtract 5 pi over 3, and that will give me pi over 3. I know some of you sharp ones have been laughing at me for failing to get this very quickly, but we got there eventually. So pi over 3 is the same thing as 60 degrees, and this angle must have the same ratios as 60 degrees. So we just need to use the ratios for 60 degrees. It must have the same ratios because 60 is its reference angle, right? So, and that's why those common ratios of the common angles are important. So the sine of 60 degrees is root 3 over 2, but remember in this quadrant only cosine is positive. Only cosine is positive. That means that this answer has to be negative, right? Because we cannot expect sine to be positive in that fourth quadrant. The cosine of 60 degrees is a half, and it's positive because cosine is positive in that quadrant. And the tangent of 60 degrees is root 3 over 1, and it's also negative because in that quadrant tangent is negative, only cosine is positive. So if we summarize these things, if we summarize all of these values of the ratios that we got from this unit circle, we can summarize them on this unit circle like this. Because remember we said that the sine of the angle in a unit circle is equal to the y coordinate, and the cosine of the angle is equal to the x coordinate, right? and the tangent of the angle is equal to the y divided by the x coordinate. So when you look at the first one, pi over 6, which is the same as 30 degrees, this x coordinate is the same thing as cosine of 30, right? Because, cosine of pi over 6. Because the x coordinate has to be the cosine, and this y coordinate is the same thing as the sine of 30 degrees. So that's how you can see them on a unit circle. This one is the 45-degree angle. The second one, the x coordinate is the cosine of 45, and the y coordinate is the sine of 45. And the third one is the 60-degree, and these are the common reference angles. The x coordinate is the cosine, the y coordinate is the sine. So any other angle in this unit circle that is coterminal, that has a reference angle that's equal to any of these three angles will have the same exact ratios as these three angles. But you have to respect this rule that here all is positive, here only sine is positive, here only tan is positive, and here only cosine is positive. Okay, so this is the thing summarized, showing you the y coordinates and the x coordinates, right? The y coordinates and the x coordinates. Remember, x coordinate is cosine, y coordinate is sine. So the cosine of pi over 3, just look for it. Pi over 3 is 60 degrees. The cosine has to be half. The sine of pi over 6 is 30 degrees. The sine is the y coordinate, so that has to be a half. So yeah, now that you know all of these things, yesterday you were supposed to fill out these angles in radians. Now what you need to do is go and do the sine, cosine, and tan for each of these angles, right? Sine, cosine, and tan for each of these angles. Tomorrow is when, after we've talked about this, is when you will do the cosecant, secant, and cotangent. Yeah, don't worry about those words, you will do them tomorrow. So what's the reference angle for negative 170? Remember, if negative 170 is, because if this is 0 and this is negative 90, this will be negative 170, negative 180. If that's negative 180, negative 170 surely should be somewhere here, right? Somewhere there. That should be negative 170. So the reference angle is simply the angle that is coterminal with this one and starts with the x-axis, right? So the angle starting with the x-axis is this angle here. That angle is 10 degrees. 10 degrees. Since this is negative, the angle that is a reference angle for negative 170 degrees will have to be equal to negative 10 degrees. So the ratios for 10 degrees, and you can try this on your calculator, the sine of negative 10 must be equal to the sine of negative 170, right? You can try this on your calculator to prove me wrong or right. The reference angles must have the same ratios as the other angle that is coterminal, or the bigger angle. And this angle, this reference angle, always has to be an acute angle. Acute meaning that it is very, very acute. Just kidding, from 0 to 90 degrees, right? Find the reference angle, the quadrant of the terminal side, and the sine and cosine for 225. 225, I know this is 270 degrees, and this is 180 degrees, so 225 should be somewhere in here. If I want to find the reference angle, I need to look for the angle that this 225 makes with the x-axis. The x-axis, please. Many of you will be tempted to use this angle. It is wrong. It has to be the angle with the x-axis. So to get this angle, I'll just get 225 minus 180, which is, I do not know, 45 degrees. Yeah, 45 degrees. So that means that the reference angle for this is 45 degrees, right? The quadrant of the terminal side is the third quadrant. Let me just write here. Reference is 45 degrees. Quadrant of the terminal side is the third quadrant. The sine of 225 degrees has to be the same as the sine of 45 degrees, right? Has to be the same as the sine of 45 degrees, and we know that that's root 2 over 2. The cosine also has to be the same as the cosine of 45 degrees, and we know that that's also root 2 divided by 2. So this is how, even without a calculator, you can find all of these ratios of any angle that you're interested in. If cosine t is 1/7 and t is in the fourth quadrant, find the sine of t. So t is in the fourth quadrant, right? The cosine of t is 1/7. So I know the cosine of t is 1/7. So I know that the sine in this quadrant will have to be negative, right? If this is my angle t here, if the cosine is 1/7, then that means the adjacent is 1 and the hypotenuse is 7. So that means I just need to find the opposite. So I'll find opposite. I know a squared plus b squared is equal to c squared, where b is my opposite. A is 1 squared. I need the opposite is equal to 7 squared. So b squared is equal to 48, because this is 49 minus 1, which is 48. That means the opposite is square root of 48, and you can simplify this. Square root of 48 is the same as 48 is 16 times 4, is it? 16 times 4, no, 4, 7, no. 48 is, what's 48? Isn't it 16 times 4? Sorry about this, guys. 48 divided by 4, 12. Okay, 48 divided by 16. 3. That's what I thought. So 48 is the same as 16 times 3. So that's the same thing as 4 root 3, right? That is my opposite. So to find the sine is going to be opposite, which is 4 root 3, divided by hypotenuse, which is 7. But this has to be negative, because sine is negative in this quadrant, right? Sine is negative in that quadrant. So that's how you do that. They want me to find the coordinate of the point on a circle with radius 8 corresponding to an angle of 7 pi over 4. So let's first deconstruct this 7 pi over 4. 7 pi over 4 obviously is the same as 4 pi over 4 plus 3 pi over 4, right? 4 pi over 4 is 1 pi, is a full pi. I don't need to draw this one. 4 pi over 4 is a full pi, so that's going up to here. And then I need to add 3 quarters over pi, right? 3 quarters over pi. This is 1 quarter, 2 quarters, 3 quarters. So that's my 7 pi over 4. Now if that's 7 pi, if that's 7 pi over 4, then I need to figure out what this angle is here. So if that is 7 pi over 4, then I know the 2 pi would be 8 pi over 4 minus 7 pi over 4. So that means this is just pi over 4. I'm using 2 pi because this would have been 360 degrees. So this angle is pi over 4. So I know that whatever this angle is, it has the same exact ratios as pi over 4, which is 45 degrees, right? So I know the coordinates. Sine of that angle has to be equal to the y coordinate, right? And the sine of 45 degrees is root 2 over 2. But this is true if it is a unit circle, meaning if it is just 1 unit, right? However, this is 8 units, right? The circle has a radius of 8 units, so I need to multiply my answer by 8 units, and I'll end up getting 4 square root 2, right? That is the y coordinate. And the x coordinate is cosine theta, which is equal to x, which is equal to root 2 over 2, but the circle has a radius of 8, so I have to multiply it by 8, and I end up getting 4 square root of 2. Okay, evaluate sine, negative 4 pi over 3 times cosine pi over 2. Figure out what this angle is and what this angle is, and then substitute with their ratios. Cosine pi over 2 is the same as square root over 2, square root over 2. 4 pi over 3, let's see what angle that is. 4 pi over 3 is the same as 3 pi over 3 plus pi over 3. So 3 pi over 3 is the same as 1 pi. Then I add a third of a pi, and I know a third of a pi is 60 degrees. So this angle must have the same ratios as 60 degrees or negative 60 degrees. The cool thing about sine that you will notice, you can test this on your calculator, the sine of a negative angle is also equal to a negative value. But the cosine of a negative angle is not equal to a negative value. That is equal to a positive value. So you need to look out for that. However, this is sine, so I know the sine of negative 4 pi over 3 will be equal to the same thing as the sine of negative 60 degrees, which I know is negative root 3 over 2. So my final answer here is just negative root 6 divided by 4. Yeah, sorry the video is long, but some things needed to be explained, and yeah, you can do the homework and then go and finish the sine, cosine and tangent sections of that worksheet. Bye.